There are two ways of looking at a brain currently. You can look at the brain non-invasively. We're talking about the human brain. So you can look at the human brain non-invasively using MRI, magnetic resonance imaging, or computerized tomography. But MRI is really the tool of choice because it shows a lot of detail of the soft tissue, and the brain is very soft. The other way of looking at the brain is postmortem, necessarily, when you want to see tissue at a microscopic level. The MRI is a wonderful technique because it allows you to essentially have a view, a low resolution view, but still a view, quite detailed view of the brain without having to, when the person is alive. And so you can actually use that to make conscious decisions about treatment or to see what's going on. As I said before, it's very low resolution, so not all the answers are there. When the brain is looked at instead in flesh and blood, when the real brain is looked at, there are techniques, they're called histological techniques. There are techniques to process these brains and to be able to then look at individual cells, look at individual fibers, and that's where you observe the pathologic phenomena that creates the disease in the first place. For example, Alzheimer's disease, the symptoms are dementia and other organic symptoms. But when you look at the brain using MRI, you can see shriveling, you can see a loss in mass, but you don't really see the actual hallmark lesion of Alzheimer's, which are the plaques, the tangles. In order to see those, you have to work on postmortem brains, postmortem donated brains. And when you slice them and stain the slices, it's a procedure that's it's actually an old procedure. It was, histology started 200 years ago. But it is still the only way we have to look at individual cells, to look at processes that cause the disease. And it's extremely important, and it's still the gold standard. These days, of course, just like anything else, even this branch of neuroscience has entered the digital domain. And so now we use digital imaging to look at cells, and we can catalog them, and automatically there is a beautiful quantitative tools that allows us to study the brain at microscopic resolution.